So in this case, we are going to consider as a continuation working with the compound gear trains. Remember, in our previous class, we managed to work with a simple, all right, a simple gear train that you're given, where the major case is that each gear will be connected to its shaft. So A, as the driver, is connected to shaft 1 and B to shaft 2 on the output. But when we are to consider a compound gear train now, we are going to notice that compound gear trains are gear trains with more than one gear on one shaft. More than one gear on one shaft. That is the condition that we now have. More than one gear. And that's where we have the intermediate. Let's consider this condition, which is a basic view of a compound gear system or a compound gear train. You will be having gear A and B, just like before. We had gear A and B. And gear A was connected to the input shaft. Its input shaft. All right, that is what we had. And B will be connected to the output. But in our case, that's not. B will be connected to gear C. So it's A driving B, then B will be affecting C through the intermediate. So in between here to this one, we'll have an intermediate so that we can have gears C and what? C and D. So this will be our case connected through the intermediate so that we now have gear C and gear D through what? The intermediate. This will be our condition. So if we had a shaft on the input as shaft 1 on the input, we had this one as 1. The intermediate is connecting B and C. So that's our second shaft, taking it as a shaft 2, connecting what? Connecting C and D. I mean, B and C here. More than one gear that we have on a single shaft. We have got B and C. So the intermediate will be the second. To gear C, gear D, like that. Efficiencies can be found or can be calculated or determined. And these efficiencies will be affecting when we consider it will be between. Efficiency will be called between A and B. If there is efficiency, it will be taken as efficiency between gears A and B. Efficiency taken will be taken as efficiency between gears C and D. And that will be our second efficiency that will be taken between what? C and D. So that's a basic view of what we have. But now, the compound gear train used in hoisting a drum. a drum. It means the whole system here at the output where we have D, all right? Remember, we've got input shaft, then we've got the intermediate. What was supposed to happen at D? We must have a shaft on the output now. We have output. D is the last gear that we have. So that marks our output. So 1, 2, we now are at 3. We are now at position 3. Output 3. So whenever I'm going to use 3, I'm referring to the output for a compound gear system. 2, intermediate. 1, input. So let's say it is hoisting a drum. It is in connection with the output now. This one is in connection with the output. So the drum that we have will be at a certain mass. All right, where you'll be given this drum that we have, it is at a certain, you're given the mass of that drum. All right, M representing the mass. And as we consider the issue of the drum, where it is considered, we are going to notice that when it comes to the radius of the drum, it is the same as the radius of gyration. For a mass lifted by a drum, the load behaves like a point mass at the drum radius. So the radius of gyration will be the same as the radius of the drum. Okay, I'm going to explain that one later on in detail, but that is what you basically have. So there now we must be careful. Remember, we are going to refer as what we had these equivalent moment of inertia, this and that. So for you to obtain those, you must have the moment of inertia that is affecting on the input. So on the input, they must give you to say, okay, it is combined. In our previous case, when we're dealing with a simple gear train as what we had, it was A, the shaft here, and A, they told us, all right, this combined everything there. But let's say it's not combined now. We have to calculate separately the moment of what? The moment of inertia. It follows that the moment of inertia at the input, when you say the input combined everything, I1, it carries everything that we have, the shaft and A. So they can give us a condition where the shaft actually has the same moment of inertia throughout. It is a constant value, but it is supposed to be taken from the moment of inertia of the shaft that you are having on the input plus the moment of inertia of what? Gear A. You are focused on the input. So it must take that of the shaft and that of A. But if they say this is combined, everything, the shaft and that of it's combined, then there's no need for you to use the formula. You just take your I1 as it is on the input. The same thing when we consider I2 for the intermediate. The intermediate, it connects B and what? B and C. So meaning to say we must have the moment of inertia of the shaft first plus the gear B and gear C, because intermediate connects B and C. So you must add now the moment of inertia for gear B and that of what? Of gear C. You see now. At the output, the moment of inertia there must consider what we have at the output. So at the output, what we have is going to be the shaft first. Then as we can see, the output here, it is just like an intermediate because it is carrying D and the drum. So gear D will be having what? The moment of inertia for that gear D. What about the drum? Because when you have the drum, it is carrying a certain mass. So the moment of inertia is there for the mass that we are given. mr squared or mk squared for the radius of the drum or the radius of gyration. So there is a moment of inertia there considered from a given mass of the drum. So let me just write as drum from the drum, but it will be just Im. So let's just write plus the moment of inertia of what? Of the drum. So from the drum, because it has a mass. So that will be our Im for that given mass. So those are now referred to as total moment of inertia for that one, two, three. Unless they give you that it's combined, everything is combined, B and C, everything, like what we had when we were dealing with those simple gear train, they were telling us that it is combined, they were referring it like that. But when not given, then you must consider to say, am I having the shaft? Am I having the moment of inertia for A? Am I having B and C and also for the shaft? Am I having D and the drum and also for the what? For the shaft. That will be your moments of inertia in total. But remember, these are used, I1, I2, I3 are used to calculate equivalent moment of inertia. Remember our previous class, we dealt with the calculation of the equivalent moment of inertia where we are not given the efficiency or where the efficiency is at 100% and where we are given a certain value of efficiency. So this time, all right, let us just write moment, equivalent moment of what? Of inertia. Equivalent moment of inertia. Remember, it can be referred input or output, but this at 100%. At 100% what? Efficiency. Or if they do not specify about the efficiency, these are the formulas that will be best. But like I said before, guys, whether you use formulas that you've got efficiency straight, still it's one and the same thing. So we have the one referred to the primary, which is the input, at the input. So this time we have I1, I2, I3. So as we move from the input, it's going to be I1 plus I2 affected with the speed. I2 will be affected with the speed N1 and N2. But what is happening now is that it's referred to the input. So N1 is always in the denominator when it is like that input. So it's N2 over N1 squared plus we move on I1, now I2, we move on to I3. So I3 definitely we're going to need speed at the output N3. So that will be N3 over what? N1 referred to the input. It's over N1. So this is what you're going to have. Referred to the what? Referred to the input. To the input. Of which you can actually have those efficiencies. All right. On efficiencies, remember we have efficiency 1 and what? And 2. So we can have those effects on the input. Remember always efficiency divides. So it was going to be here, efficiency 1. Then here we divide by efficiency 1 and 2. So it will be 1 and 2. So that's if you want to use that. But you know that since it's at 100%, So that'll be 1. So there won't be any effect, all right, if you want to use efficient. But I'm going to write these formulas later on. So let us move on to another one. We can also have when it is referred to the output this time. So it's going to be IE2, refer to the output. So, sorry, output is going to be 3. This time there are 3 of them. So it's IE3, not 2, IE3. So you must be very careful there. So you start with the 3, 2, 1, just like here, 1, 2, 3, because you started with input. Output, so you're going to start with 3. I3 going down like that. Plus I2 referred to the what? Output. So it's definitely going to be over any 3, the output. But what is it that is going to affect this time? It is any 2, just like what we had. So it's going to be any 2, but this time over the output. Plus, we move on to I1. Refer to the output, guys. So it's any 3, but this time from what? From any 1. So it's going to be any 1 over any 3. Just like that. So as we can see, that is the effect that we have. It's now referred to the what? To the output. So N2 over N3, N1 over N3. That is what you have. Referred to the output. So the equivalent moment of inertia, guys, those can be referred as total. Other textbook, they write as IT. Remember, I talked about that, but here it is best to know, okay, we are actually dealing with this, we are actually working with this. It will be easier for us to have that. All right. When the efficiency is referred as any other efficiency, not 100%, with what? Efficiency, but this time not 100%. We have to consider the efficiency on our calculation referred to the input. You divide by what? Efficiency. So this gonna divide here and divide here. Okay, let me just write the formulas. So it was gonna be I1 plus I2 over the first efficiency plus, oh, sorry, the bracket there. Remember we had N2 over what? N1 squared plus I3. So I3, the output, you must divide by both efficiencies, N1 and N2, both N1 and 2 of those efficiencies. All right, then this remains as it was, N3 over what? N1. So that's referred to the input. Okay, then when referred to the output, which is 3, when referred to the output, remember you multiply the efficiencies, will multiply, that will be the effect. So whatever that we had here will be under multiplication. But remember what we had here as it is, but you have to multiply, multiply. That is the only effect on the output. So that will be I3 plus I2 times the efficiency. So that is, you must consider the second one. All right, that's I2 times its efficiency. Okay, then this will be N2 as it is. All right, then we move on to that is I1, and the efficiency is 1 and what? 1 and 2. Okay, and this is N1 over N3 squared. All right, so this is what you are going to consider we with our calculations. All right, with our calculations, we are going to consider where there is efficiency and some other calculations. It will be a condition where the efficiency is actually at 100%. This is supposed to be N2. This one, sorry for that. Let's correct here. It's supposed to be N2. On the product, supposed to be N2. So, guys, just try to memorize these formulas according to this, all right? If we check the formula sheet, the problem with the formula sheet is not yet advanced, like it's not yet updated, guys. So in terms of N6, guys, it's not yet updated, but just try to play around with this information as an individual. So I referred back N1, the efficiencies, what we have on our efficiencies here, 1 and 2 from what? A and B. I mean, 1, it's from A and B. 2, it's from gear C and what? And gear D. So this is what you need. And all other calculations still remains the same. Still the same. There's torque, what, still the same. So just refer the basics. So this was a direct application where a compound gear train is used in hoisting what? A drum. And we saw the effects of the formulas. Sometimes you'll be given a condition where you have, there are so many conditions actually. We are going to look into them separately. But just for the sake of time, you can have an electric motor driving a drum. An electric motor driving a drum. An electric motor driving what? A drum. And that's through a reduction gearbox. When you have this condition, mostly what you have will be of a simple gear system, but we are still on a compound to say the issue is on the shaft to be carrying two things. It can be gears or it can be uh, a motor or a drum like what we saw. Still, it is under a compound when it is like that. But this time, you take your gear A and B, the motor connected to A, all right, so I'm just going to give you a basic view. The motor connected to A like this, then B to the drum. All right, so this is now to the output. So here it will be our motor, and this will be our drum. So in this case, it is just a normal view of how it's gonna look like. This electric motor is driving what? A drum. So it will be just this condition of A and B, having gears A and B, and it will be the input, and this will be our output. So when you consider now, this shaft is carrying A and the motor, and this shaft is carrying B and what? The drum. So you must be very careful now when it comes to the shaft. It's only that for the motor, there is no moment of inertia to be calculated, but for the drum, there is a moment of inertia to be calculated due to the mass of what? Of the drum, that is, it will be lifting a certain mass. So when you consider that, you are going to see that just like here, we noticed that this affects the moment of inertia. So the input this time as you consider I1, it will be just what you have on the input as it is. So it will be carrying what you have on the input. If you have got I1, let's say they gave you the combined, because when it is like this, it is different from a view of here, what we had here before. When we have got this intermediate, we have to consider the shaft separately. But let's say you now have that I1, you now have I2. You have those ones already. You have I1 already, like you're given the combined part. That's your input. I2, they will give you a combined, it will be of the gear now, to the gear. They'll give you that one as the gear. So in order for you to have the, so here let's just say I in is equal to I1, which is combined. Everything has been combined there. Then on the output, you must take the combined of I2 from B and the shaft if you are given that. And also you must consider what? The mass of the drum. So you must consider IM for the drum. All right, this will make sense if I'm explaining it from a question. All right, so when you have got this condition, it will make sense. But for now, just consider that it is something that you must put into consideration. It is something that you must put into consideration. And as we have the motor this time, we can calculate the torque that is required by the motor. All right, the torque that is required by the motor to accelerate the system, the whole system that we have, the whole system as it is, the torque to accelerate the whole system. The whole system. All right. So it is actually torque required. Here, let me just remove this, guys, and put it this way. Torque required by motor, by the motor to accelerate the whole system. So when it is like this, you are referring to the whole system. You must have the equivalent moment of inertia now referred to the input because the motor is on the input. So that torque to accelerate the whole system must be considered from the input. So you must use equivalent moment of inertia for the input times angular acceleration of the input. You must consider what you have on the input now. But the question is, what about this equivalent moment of inertia referred to the input? Is it the same as I calculated when I was having this? No. Because here, guys, if you check, we had 1, 2, 3 outputs. Shafts, okay, according to our diagram. And we consider also according to what we have there. This time, it is just A and B. Input, output. So we cannot have the calculation like what we had. In this case, equivalent moment of inertia in the input will be equal to I1, which is the input as it is. So it's I1 plus I2 into, as referred to the input, is going to be N2 because it's just 1 and 2. So the speed is going to be N2 over N1 squared. As we had this one from a simple gear train. Remember, from a simple gear train, this is just a layout of a simple gear train that we have when we have got an electric motor driving what? Driving a drum. We had this formula before. So this is your equivalent what? Moment of inertia. Angular acceleration you might be given, or there might be somewhere where you are supposed to calculate it from according to the information that you are given on that particular question. Let's say you have the torque in the input and also in the output. It also follows that it can be used to calculate the torque required by the motor to accelerate the whole system. So you're going to use the formula Tn, the input torque, plus the output torque over the gear ratio. It's another formula that can be used provided with the information that you are given. Remember your gear ratio as you calculated before from the torque, from the speed. So let's say you do not have, you can use speed. If you consider speed, it's N1 over N2. If you consider it's omega 1 over omega 2, which is equal to alpha 1 over alpha 2 for the angular acceleration. So remember those ones. So that's basically what you're going to need. That's basically what you're going to need. This is the torque required by the motor, but it can be torque required to accelerate the wheel or the driven gear. You're just focusing on that gear. This is not about the gear system. This is not about gear A or gear B. It is about the whole system. The whole system. So if I want to affect only at A, that is the torque required to accelerate the pinion, the input. I mean here A, gear A, which is what? The driver, the pinion. So that torque to affect A, our driver or the pinion, must be from the moment of inertia of A times angular acceleration for A. For gear A, if it is for B, it must be taken from B. So that is the effect. Now, remember when I was talking about I1 there, I was saying it's a combined thing. Where it is separate, you must see the shaft and A separate. So that moment of inertia of A separate is the one that we need. Only that of A. Only that of what? Of B. So this is required to accelerate gear B, which is what? The wheel or the driven gear. Then this is for A, gear A, or the pinion, the driver. So this is what you have. And I talked about the radius of gyration before. To say the radius of gyration and radius of the drum will be equal, since it's For a mass lifted by a drum, like this, for a mass that is lifted by the drum, the load behaves like a point mass. So the load behaves like what? A point mass. And at the drum radius. So it affects at the drum radius. So therefore, radius of gyration is same as the radius of what? Of the drum. And that is used when you are to calculate the moment of inertia for that mass that is being lifted. All right. The input torque to be applied to the driver or the pinion to accelerate the hoisting drum is different to what we had yet to. It was the torque required by the motor to accelerate the whole system. But this time, it is the input torque. Let me write it down. To be applied to the pinion or the driver. Okay. To accelerate. So it must accelerate the hoisting drum. The hoisting drum. The drum is involved, but we are talking about input torque. But the drum is at what? At the output. So the formula will be the equivalent moment of inertia referred to the input times angular acceleration of the output there, since the drum is on the output. So you affect to the output. Output. Just like that. It is the equivalent moment of inertia that is referred to the input that will be used. That is gonna be used. So with this information, I think you can even answer, guys, now you can answer as many questions now. From what you heard from the first video, this and that. I'm just gonna bring examples, one or two. Then from that, I think we'll be done. We just have to look at the last one, which is the last one, the warm gear. So that one, it's just separate to everything that we are doing right now. You'll be seeing like we are doing something else, something different to what we had. So take note of this part of your compound gear train. Use it to answer any questions as you have these formulas, and try to memorize and apply the formula, since your formula sheet is limited. So do not be caught on the wrong side in exam, trying now to figure out the formula sheet where it is not necessary. So please memorize where it is applicable, but you can even trace and see what is happening here. With time, you can just, okay, this is the question on its own. Read it properly, because you see these diagrams, I'm going to also re-expand them. The question is important, how it is given, how the question is given, because we might not have the drum at the end. It is how it is given. So here I'm covering like almost everything. And for an electric motor, it will be a simple system that you'll be having. All right. So just like a simple gear drive. That's when an electric motor is used in driving a drum system, unless they are to expand it. If they expand it, Then we have to answer according to that. We are going to look into questions so that we see how do they ask these questions. And also do not forget kinetic energy. Also, yes, those kinetic energy calculations, as we had before, half of what? Moment of inertia omega squared. So those can also be used because there is moment of inertia, there is angular velocity. So they can also ask you to calculate the kinetic energy depending, is it the whole for the whole system where you must combine or have the total moment of inertia for the whole system. Revise those basics and other formulas from your previous levels, especially your science and 4 and so on. So that is it, guys, till we meet again.